We left off in the last video on part A right here. What are all the possible new hourly wages for the new year? So I want the new ones including the raise, right? So if you started off with $9, you could either get a $1 raise or a $3 raise. So my two possible combinations are $10 and $12. That's taking the old wage of 9 and adding the two possible combinations. Now if I have $12, I could get a $1 raise or a $3 raise, right? So that would end up being either 13 or 15. Now if I started off at 15 and got a $1 raise, I would have 16 or 18. What is the probability of an employee being assigned a $9 wage and a $1 raise? $9 wage and $1 raise. Show your work. All right, you see this word and, automatically I want you to think intersection, multiply. Right? We talked about and or in probability and intersection multiply. So the intersection of a $9 wage with a $1 raise. Now the important piece of information that we didn't note up here, assume X and Y are independent events. So we can just use the simple multiplication rule if they're independent, right? The probability of X and Y would be, probability of X intersection Y would be the probability of X multiplied by the probability of Y, and we can do that because they are independent, right? So let's figure out the probability of a $9 wage. We want to find 9 intersection 1, right? So that's going to equal the probability of a $9 wage times the probability of a $1 raise. So what's my probability of a $9 wage? That's 0.3. Times the probability of a $1 raise would be 0.7. So the probability of one times the other, 0.3 times 0.7, will give me 0.21. All right, so now I know how to fill in the rest of this probability table for N, the combination, right? N, which is X plus Y, which is our new wage. And I do that by multiplying the probabilities right here. All right, so I'll do one more with you, and then I want you to fill in the table on your own. So the probability of 9 intersection 1 will give me a new wage of 10, right? 9 plus 1 is 10. So 10 here, the probability is 0.21. All right, my next one is 12. All right, so to get 12, I would need a $9 wage and a $3 raise. So to get a $9 wage and a $3 raise, all I'm going to do is multiply these two probabilities. So 0.3 times 0.3, which will give me 0.3 times 0.3 gives me 0.09. So my probability here is 0.09. Go ahead and fill out the rest of the table by yourself. Pause the video and come back when you're done. So here's the completed table. What you should have done is for each possible scenario, we should have just multiplied the probabilities, right? So for instance, this $13 would be $12 base wage times the $1 raise, so 0.45 times 0.7. Now I know this is a valid probability distribution because all of these are between 0 and 1, and when I add them all up together, which I did, trust me, you get 1, which is a valid probability model. All right, so now it asks you to find the same thing, the mean, the variance, and the standard deviation. All you're going to do is put the new wage in as L1 and the probability in as L2, just like we usually do, and then go to Calc and hit Enter and make sure L2 is your frequency list. So go ahead and pause the video, do that, and then check your answers when you come back. All right, I trusted you worked them out on your own, and you should have gotten an expected value of 13.45. A standard deviation of 2.40, and a variance of 5.76. How did we get the variance again? We squared the standard deviation. That's their relationship. So 2.4 squared gives you 5.76. All right, now the last one. If n is x plus y, complete the following in terms of x and y, meaning I have to write the formula using x and y. So mu sub n, or our mean, was 13.45. Looking back, this was x and this was y, right? So look at my mean of x and my mean of y. Could I do something with these two that would make it equal 13.5? I hope you're thinking add. That's what I was thinking too. Let's try it out. 11.85 plus 1.6 equals 13.45. The mystery of math. So 11.85 plus 1.6 gave me the new mean, right? So in the future, I don't need to do all this probability distribution. I already know the rule. We proved it out, right? Mu sub n, or the combination of x and y, is going to equal mu sub x plus mu sub y. I just need to add the means to get the combined mean. Standard deviation, not so much. Standard deviation is a little tricky. And now you're going to see why I had you calculate the variance for each one. So looking at these, you can't really compare these standard deviations, right? You cannot add 2.22 plus 0.92. It won't get me 2.4. We can try, though, just in case you're like, Miss Lucas, it looks like it might. 2.22 plus 0.92 is 3.14. So you were wrong if you were thinking that, but I appreciate your healthy skepticism of my teaching. All right, so what we must do, though, is look and see if the variances have a pattern. 4.93, 0.85, and 5.76. Well, that looks like they add up, right? So let's try that. 4.93 plus 0.85 gives me 5.78, which is really close, and it's only off because we rounded, right? I rounded these standard deviations before I squared them, which I should not have done, my bad. But so that gives me, I'm 0.02 off because of rounding. So, in order to calculate the standard deviation of the combined random variables, I would need to do the square root of the variance of x plus the variance of y. All right. See, when I add up the variance of x and variance of y, it gives me the variance of the combination. And in order to get back to standard deviation, I need to take the square root, right? So if I took the square root of 5.76, it would give me 2.4. So that's ultimately how I get my combined standard deviation. I need to get the variance of the two variables, add them together, and take the square root. Don't worry, we'll do more examples. This was just proving it all out. Now we don't need to prove it out anymore because we know the rules, and here they are. I've put them in a chart for you. So, combining the random variables, here's my mean. All I need to do is add them together. Now I know what you're thinking, Miss Lucas, what if we're subtracting? It works the same way. You add if you're adding, subtract if you're subtracting. So mean is easy. If you've got the mean of the two random variables and you want to combine them, just add or just subtract. That's all it does. Now standard deviation is a little bit different, right? So the variance would be standard deviation squared. Your variances always add, they never subtract, right? So my variances of the sum of x plus y and my variances of the difference of x minus y will be the same thing. You square the standard deviation of x and add it to the square of standard deviation of y. So my standard deviation is going to be when you add the two squares together. So it's really the Pythagorean theorem of statistics. I'm bringing my geometry into my stats. All right, this may all look kind of confusing, but we'll do two examples to help you get it figured out. All right, so example 1. A large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let x equal the number of cars sold and y equals the number of cars leased during the first hour on a randomly selected Friday. Based on previous records, here are x and y, right? So this is x and this is y. Cars sold versus cars leased. We want to define t as x plus y. So here is our combining random variables, right? Combining random variables. And we know the rules for this already. They're up in the chart above. Assume that x and y are independent, and we have to do that so that our t probability distribution, we can just multiply x times y to get the probabilities for t. All right, so find and interpret mu of t. All right, so take a minute and look at our mu rules, right? We're adding, so we're in this column. So the mean is just going to be the mean of x plus the mean of y. So mu of t is going to equal 1.1 plus 0.7, right? I'm adding up the means of these two. So mu of t is going to equal 1.17. I'm sorry. That's why you always use a calculator. 1.8. Mu sub t is 1.8. Okay, and then our interpretation. So mu of t over many Fridays, the dealership expects to sell and lease about 1.8 cars in the first hour. All right, now calculate and interpret the standard deviation of t. All right, remember this is a little bit different, right? I need to find the variances first. So all I'm doing to get standard deviation of t is I'm taking the square root of the variance, the sum of the variances, right? And all I do to get variance is square the standard deviations. All right, so let's plug everything in. Standard deviation of t is going to equal the square root of, let's see, 0.943 squared plus 0.64 squared. Remember, I don't have the variances, I only have the standard deviation, but to get the variance I just need to square them, which is why I'm squaring these two. So I add the variances and then take the square root to get back to the standard deviation. So I'll give you a second to calculate this in your calculator and try and interpret standard deviation of t. Okay, so when I did the calculation, I got 1.14 when I did all this right here. And then here's my interpretation. The cars sold or leased by the dealership in the first hour of a randomly selected Friday typically varies by 1.14 cars from the mean of 1.8. All right, so remember standard deviation is typical variation. All right, number 3 combines all of our knowledge. The dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and the standard deviation of the manager's total bonus B. All right, so before we combine the random variables, I need to transform them. And I'm transforming them by multiplying by $500, right? So I need a mu bonus of sold cars, so for bonus selling, a mu for bonus leasing. I need a new standard deviation for bonus selling, and I need a new standard deviation for bonus leasing. All right, so all I'm doing is multiplying by 500, right? So I'm going back to my original chart about transforming. If I'm multiplying, my measure of center and my measure of spread changes. So I'm multiplying everything. All right, so my original mean for x was 1.1. All right, so I'm going to do 1.1 times 500. That's going to give me my new mean of 550. All right, now my leasing was 0.7, and I only get a $300 bonus for leasing, right? So 0.7 times 300, it's going to give me 210. So that's my new mean for that. All right, now my standard deviation changes as well because we're multiplying, right? We're not adding or subtracting. So my standard deviation here was 0.943, and we're also going to multiply that by 500. 0.943 times 500 gives me 47150. So that's my new standard deviation there. And then of y, it was 0.64. So I'm also going to, I'm not multiplying by 500. I'm multiplying by 300, the leasing bonus. So 0.64 times 300, which gives me 192. All right, now that I've transformed all these, I'm able to actually combine them, right? So if I'm combining the means, my mu sub b, I'm just going to add these two. 550 plus 210. So my mu sub b, my mean of the bonus, is going to be 550 plus 210, 760.